Okay, I want to show you some knots that I've made using wire. It's a lovely exercise in getting a feeling for how the knots form. So here we start with the classic trefoil knot, 3 crossings sort of in one piece, and I'm going to be talking about the Conway tangle notation, and so this has notation 3. Now we move up to the the knot with 4 crossings. Now, if you are looking at what's happening here, well, there's a lot more than 4 crossings you can see. And what it's actually recording is not the number of crossings you need, but the minimum number of crossings you could use. And so here is a position for this knot, but if you look at the shadow, it's coming from a slightly different angle than the camera or the light, and so the shadow has more crossings, and as you move about sort of in most there, now the shadow has 4 crossings and the model itself doesn't. As it moves, you get lots of different crossings, and this highlights one of the problems of knot theory, because even having the same 3-dimensional shape and move it about like this gives us lots of different 2-dimensional forms, and the central question is, how do we tell when they are the same? And going in the Conway notation, this is 2, 2. So we'll now get on to the first knot with 5 crossings. Let's put the shadow. In the shadow you can see the 5 crossings, and this has Conway notation 5 because it goes round sort of in one piece, one tangle with 5 crossings. And we can move up to the second knot with 5 crossings, and this is Conway notation 3, 2. It's also the largest of the knots I made. I got more consistent on the size as I was building them. So now the first knot with 6 crossings. Now if you remember, 3 was the first one we had, and then we had 2, 2 with 4 crossings, and then for 5 it began with 5. Now for 6 we don't begin with 6, because if you take a sort of loop going around a torus that crosses itself 6 times, it won't join up into a single loop. It will actually join up into 2 trefoils. So this is 4, 2. Continuing the 6 crossing knots, we have the second, which is 3, 1, 2. So there's a trefoil basically in there that then has some extra pieces added on. There's a single twist tangle and a double twist. Note that the single twist and the double twist do not give knots. They can be untangled. So this is the third with 6, and this is 2, 1, 1, 2. And that's it for knots with up that can be drawn, allowing up to 6 crossings. Now we're up to 7 crossings, and just like 3 and 5, the first is just a loop going around itself twice, weaving out of itself. You can think of these things as similar to stellated polygons. And in this case, the symmetry isn't harder to draw. Well, the symmetry is I'm bending wire with my hands, and so it's hard to get something the same curve twice. Second knot with 7 crossings, Conway notation 5, 2. And you can think of this knot as taking a loop of wire, twisting it round itself 5 times, and then putting a loop putting the ends of the loops together to stop it from untangling. And so here we have the third knot with 7 crossings, and this is 4, 3. Note that the tangle with 4 crossings doesn't form a single knot on its own, but it can be used combined with other things that will allow a knot to form. Also, notice that in several of these models, I have a little number, you can see here, and that is a different notation for the knots. That's the Alexander notation, and that they just took the numbers of crossings and just then listed the knots. But this is now 3, 1, 3 for 7 crossings. You notice that the way that the numbers are given do seem to go from simpler knots to knots with a more complex structure. So we come on to what they would call 7, 5, and it is now 3, 2, 2. So as you list them in their order, it's sort of a natural way to list with the Conway notation. So there is some sort of there's some sense within the list that they have. So here's 7, 5, and this is 7, 6, which is 2, 2, 1, 2. And that leads us to the final knot, 7, 7, or 2, 1, 1, 1, 2, in the Conway notation. And that is our list of all knots up to 7 crossings.